Math people, welcome back to another digital math lesson for Algebra 1, talking about the last section in the chapter, Chapter 10, Lesson 6, on trigonometric ratios. Say it with me, trigonometric. Trigonometric. Say it one more time. Trigonometric. So we're going to talk about trigonometric ratios, and you're probably thinking, what is this garbage? I did not need this in my life. Why are they throwing such big words at me right now? Well, it's actually pretty easy, pretty simple to kind of navigate through, and it sounds a lot more complicated, looks a lot scarier than what it actually is. So our objective today is to find and use trigonometric ratios. Now, ratios you probably are familiar with already. A ratio is just a comparison of two numbers using division. We're going to be talking about trigonometric ratios using sine, cosine, and tangent. Sine, cosine, and tangent. So let's jump in this, huh? The three starting points, the three things that we should talk about first for all trigonometric ratios, or trig ratios as the cool people call them, right, are sine, cosine, and tangent. Sine, cosine, and tangent. Right now, these are just words. They're just new words that don't really mean a whole lot to you. But we kind of have to figure out, well, what are they? Now, because they are ratios, we can express these as a comparison of two numbers using the division. But before we can do that, we need to go ahead and define a few new terms for you guys. The first term that we need to go ahead and define is the term adjacent. Adjacent means next to. So if this side right here is adjacent to angle A, all right, it means it's right next to. The next term that we have to talk about is opposite, and this means across from. And we can say that this side is opposite of angle A because it's right across from it. The last term we should talk about is hypotenuse. The hypotenuse, by definition, again, these trig ratios, they apply to any right triangle. And in this case right here, this side that is opposite from the 90-degree angle is called the hypotenuse. It is also the longest side. Now that we have explained these, we can go ahead and introduce a new acronym to your life that might help us remember the trig ratios. Okay, so let's go ahead and talk about SOHCAHTOA. SOHCAHTOA. Now, what SOHCAHTOA is, it's an acronym that helps us remember the exact order for all of our trig ratios, where we have our sine, we have our cosine, and we have our tangent represented from SOHCAHTOA. So represents the order for sine, for the ratio for sine. Sine is going to be the opposite side over the hypotenuse. Sine is opposite over hypotenuse. Cosine is going to be the adjacent side over the hypotenuse. And TOA, or tangent, is going to be the opposite side over the adjacent side. Okay? So if I wanted to figure out what these values were, I would simply remember, what does adjacent mean? It means next to. What does opposite mean? It means across from, and the hypotenuse will always be opposite of the right angle. So SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Right now you're probably sitting there thinking, what on earth is he talking about? That made no sense. That was all completely gibberish. He's making up words. SOHCAHTOA, that's not even a word. I looked it up in the dictionary. It's not even there. Calm down. Calm down. It's a lot easier than what you think. All right. So let's go ahead and look at problem 1. And they're asking, what is the value of sine A? Sine A. So First off, I'm going to write sine A, and the next thing I'm going to do is I'm going to circle angle A. We always want to circle, we always want to have a reference to what angle we're trying to find, because a sine for A could be different than B. All right, so sine A, so I circled A. Now sine is opposite over the hypotenuse. So what is a side length that is opposite from A? Well, opposite means across from. So 15 is the opposite. And what is the hypotenuse for this entire triangle? 17. That is a trig ratio we're looking for. 15 over 17 is a comparison of two numbers using division, and there's no way that I can simplify this. If I can reduce, I must reduce, but there's nothing I can do. Sine A is 15 over 17. That wasn't so bad, was it? Let's go ahead and try to practice finding cosine of A. Okay, so cosine of A, again, is a little different. Let's erase this arrow. We still are trying to find the value, the comparison of A. So for cosine of A, we're just going to go ahead and do adjacent over hypotenuse. Cosine is adjacent over hypotenuse. The adjacent side, or the side that is next to A, is 8, and the hypotenuse is still 17. 8 over 17. All right, that's it. What about the tangent of A? Tangent of A is going to be, well, tangent of A is opposite over adjacent. So what is the opposite side from A? The opposite side from A is 15. And the adjacent side, the side that is next to, is 8. Now, why isn't 17 adjacent? Well, 17 will always be the hypotenuse. How do I know? The hypotenuse is always the longest side of a right triangle. Those weren't so bad, were they? I don't think. I think they're pretty good. Let's practice another one. Let's look at Got It question number 1, and they're asking, what are sine, cosine, and tangent for angle E? All right, so we're going to start with the sine of E. I'm going to start by circling my angle so I know which one I'm comparing. Sine is the same thing as opposite over hypotenuse. The opposite side from E is 9, and the hypotenuse is 15. Can those be reduced any lower? Yeah. I can divide them both by 3, so I get 3 over 5 is the sine of E. Let's go ahead and do cosine of E. Cosine of E is going to be adjacent over hypotenuse. The adjacent side to E is going to be 12. The hypotenuse is still 15, and that can reduce lower by dividing by 3 and get 4 over 5. Let's go ahead and find the tangent of E. Tangent of E is going to be opposite over adjacent, and we're going to go ahead and get the opposite is 9 over 12 reduces to 3 over 4. Not too bad, right? Not too bad at all. Cool. Now let's talk about problems that may involve using your calculator, because you might have a calculator and have noticed that they have sine, cosine, and tangent buttons on them already. Now, here are a few common models of calculators that you guys might have. And what's important for these problems is that you remember to set your calculator into degree mode, because there are a few different ways that we can measure angles, and we're going to start talking about those, but degree mode is what you want to use now. The opposite of that is radian, but we're not talking about radians yet. Now, if you are interested in checking to make sure that your calculator is in degree mode, number one, it might have like a little letter that indicates degree right here, or it should say degree right here, or maybe it has like a little indicator. If you're not sure, you can check the mode or setup button and look for that. Or if you have a calculator like this DRG actually sets it into degrees or radians or gradients. So you want to push that and make sure it has degree underlined. Or the mode button on this calculator, I believe, will find your degree. If not, you guys can use a handy website called YouTube and check to make sure that your calculator is in degrees. All right, cool. Now let's look at one of the easiest problems that you might encounter all year, and this problem requires you to use a calculator. What is the value of cosine 55 degrees to the nearest 10,000? So all they want you to do is, using a calculator, type in cosine 55 into your calculator. Now, if you have a calculator that automatically, when you press the cosine button, it has this, they want you to put the degrees in right after. How do I know it's supposed to be degrees? Well, they tell us degrees. So I just type this into my calculator, cosine 55, hit enter, and I get 0.573576 that's not 436. Now they want us around to the nearest 10,000, so 10,000th would be in the tenths, hundredths, thousands, 10,000ths place, and it's going to round to 0.5736. Now if you have a calculator and you tried this and you got cosine of 55 at 0.0221, it means that your calculator is in the wrong mode. It should be in degrees, not in radians. Also, if you have a calculator that's not super fancy, it might look something like this, where it does have sine, cosine, or tangent. But when you have calculators like this, you're actually supposed to type in the degrees first and then the value. You notice that this thing is the same value as this guy right here. So calculators, you got to be careful with how they work. Make sure you take your calculator out right now and test it. Try typing cosine 55 and see if you get this answer. If you don't get this answer, you might be in radians. You might have a weird calculator where you have to put the degrees in first and then hit cosine, sine, or tangent. Check that now. Problem 3 has a little bit of a different idea behind it. To the nearest tenth, what is the value of x in the triangle? We want to try to find, in this case, the missing side length. We want to get this guy. So what do we know? Well, we know that we have an angle to work with. We have a side length as the hypotenuse, and we have this guy. So what we want to do is we want to figure out which of the three trig ratios do we use. Do we use sine, cosine, or tangent? Well, according to this, we always circle our angle first, and the angle that we're trying to find the opposite side, and we already have our hypotenuse. So which of these three, sine, cosine, or tangent, uses the opposite and the hypotenuse? Ding, 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 sine. Sine uses opposite over hypotenuse. So in this case, sine of 48 degrees is equal to x over our hypotenuse is 14. Now how would we solve for this? Well, we can go ahead and use butterfly method, or just regular algebra would probably work too. If I wanted to get x by itself, I multiply both sides by 14. And with a calculator, I type in 14 times sine 48. So with a calculator, I go ahead and say 14 times sine 48. And I get 10.4. They ask us to round to the nearest tenth, so that means that this side has a side length of 10.4. Let's do another one, shall we? To the nearest tenth, what is the value of x in the triangle at the right? So the first thing I'm going to do is I'm going to go ahead and circle the angle that I'm using. It looks like this angle is 35 degrees, so I'm going to circle this angle. And what two sides in comparison to this angle do I have numbers to work with? Well, let me just erase one of these circles because it's kind of hard to see that number. All right, so it looks like based off this angle, I have the adjacent side and the hypotenuse. All right, I have no information about the opposite, so I cannot use that. I have the adjacent and the hypotenuse. Which of these three uses adjacent and hypotenuse? Ding, 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 ding. Cosine. So cosine is adjacent over hypotenuse. Therefore, cosine of 35 degrees, because I know this angle is 35 degrees, is equal to 1.575 over our hypotenuse is going to be x. We don't know what x is. So how would I solve this one? Well, because x is in our denominator, we can probably just set this up as a proportion using the butterfly method. Butterfly method says you circle the two numbers across from each other, 1.575 times 1 divided by the other number is cosine 35. Cosine 35. It looks really weird. I'm going to rewrite this as cosine of 35 degrees. Now, I'm just going to go ahead and with a calculator figure out what is 1.575 divided by cosine of 35 degrees. I should get my answer to be 1.9 because they ask us to round to the value, so it was like 1.9227 da 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 da. They want us to round to the nearest tenth, so this is going to be about 1.9. The length of the hypotenuse should be about 1.9, which should make sense, right? Because it should be the longest side and at least has to be longer than 1.575. Cool? Cool. Now problem 4 asks us to find the measurement of an angle. So far we've been able to use SOHCAHTOA in order to find our, so I'm just going to write that down here, all right? Because it's always a good idea to write this just in case. SOHCAHTOA, if we ever need it. Alright, so far we've been asked to find side lengths, but this one they want us to find the measurement of the angle, and it's going to be a little bit different. So, you might have noticed that sometimes on your calculator, if you have sine, cosine, or tangent, above the button it has maybe a different color. Something that looks like this, where it has sine to the power of -1, cosine to the power of -1, tangent to the power of -1. These are called arc sine, arc cosine, and arc tangent, right? And we can use these to find our missing angle, okay? So, remember in the first example we asked you to find the trigonometric ratios. We figured out, well, what is sine, cosine, or tangent? And we would just say, well, what's the opposite over adjacent, blah, 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 or hypotenuse. Well, we're going to be doing the same thing here, but in order to find our inverse tangent or inverse cosine, arc or inverse tangent, in order to find our angle, we need to use these guys. And oftentimes on your calculator, it's just you hit like a shift button, and that gives you the second option, or the second button. So buttons you might be looking for on your calculator are shift or second. If you have those buttons, usually that gives you the option, and the button kind of looks like, if it's a sine button, usually in a different color writing, it usually has like that over it, and the shift or second gives you the second option. Okay? Now, what is the measure of each angle of the triangle? So let's go ahead and figure out, well, what is the measure of angle A? I'm going to circle my angle, and looking at the information for angle A, what sides do I have? Well, it looks like I have the hypotenuse here. The hypotenuse is opposite from the right angle, and I have adjacent. So which side do I need to, which trig ratio do I use that has adjacent and hypotenuse? It looks like we're going to be using cosine. So cosine of angle A is equal to, adjacent is 12, the hypotenuse is 24. Now if I want to find the measurement of the angle, all I do is find the inverse cosine of 12 over 24. So with a calculator, I would go ahead and say inverse cosine of 12 divided by 24. I can type that in just the way it is, and my calculator gives me an answer of 60, and that means my answer is 60 degrees. Go ahead and use your calculator to type that in, see if you can find the inverse cosine. See if you guys can type in 12 divided by 24 or 0.5, and you should get 60 degrees. So that means that this angle is 60 degrees. Cool? Cool. Now, how would I find the measurement of angle C? Well, angle C, I can do it the same exact way. I can say, well, according to angle C, I have the hypotenuse and the opposite. 12 is now opposite from angle C. So sine uses opposite of and hypotenuse. So sine of angle C is 12 over 24. Now the inverse sine of 12 over 24, if I type that into a calculator, inverse sine of 12 divided by 24 gives me 30 degrees. Now notice that they both had 12 over 24. But when I use cosine, I got a different angle than sine, which is the way it's supposed to work. And actually, if you think about this logically, the inside of a triangle is 180 degrees. So 90 degrees plus 60 degrees plus 30 degrees is 180. So if we found one, we don't really have to use our trig functions. We can go ahead and just use subtraction from 180. But this works the same way, and it proves it. And it's really not that difficult. You just have to know which one to use. Most of the battle is figuring out which one you're supposed to use. But remember, whenever you have to find the angles, you have to use the inverse sine, inverse cosine, or inverse tangent. The last example, we're going to turn to our book, and we're going to look at the difference between the angle of elevation and the angle of depression. Here's a good example. Here's a good picture that kind of shows you the difference. Whenever you are looking up at something, that is an angle of elevation. Whenever your eyesight would normally look straight and you have to go down, that's called an angle of depression. And using angle of elevation or angle of depression, we can actually figure out a few kind of interesting problems. So let's go ahead and look at this example from problem 5. Using an angle of elevation or depression. Suppose you are waiting in line for a ride. So this is you. And you see that your friend is at the top of the ride. This looks very much like the Supreme Screen, which is really weird colors. Alright. How far are you from the base of the ride? Well, it looks like from here, if you're looking straight across and then you go up and look at an angle of 20 degrees, you see your friend. You know that the ride is 150 feet tall, and we want to go ahead and figure out what is this length going to be. Well, notice that this makes a right triangle, and if this is the angle that we know, and we have the opposite length is 150, and we want to find the adjacent, it looks like we should use tangent, because tangent is opposite over adjacent. Tangent of 20 degrees is equal to the opposite length 150 divided by x. If we go ahead and use butterfly method, we would get 1 times 150 divided by tangent 20, and we would get about 410 about 412 or 400. They rounded to the nearest tenth of the tens place. I don't know why. They just did. About 412 feet. So he's about 412 feet back in line. So this isn't really anything different. Angle of elevation to depression. Angle of elevation means you're looking up. Angle of depression means you're looking down. Cool? Alright, that concludes our lesson. If you have any questions, visit me during office hours. I will gladly help you. I hope you enjoyed your first step into the wide world of trigonometry. Peace